We're going to solve some quadratic equations today. And today, if these are set up well, we should get complex roots. So that means that the solutions to our quadratic equations should come in the form a plus bi and a minus bi, complex numbers. So let's get started. Number one, remember to solve quadratics, we want to set it equal to 0. So we have x squared. Bring the 6x over by subtraction and set it equal to 0. Now, this one doesn't say which way to do it, but I see I have a nice even number here and a 1 here. So I'm going to use completing the square. X squared minus 6x, leave room. Subtract 12 over. Negative 12, leave room. And remember, when we complete the square, we're always adding on both sides. Half of 6 is 3. 3 squared is 9. And I've got the factors x minus 3 times x minus 3. And on the right-hand side, negative 3. We square root both sides. And remember, when you square root, you do what? Plus minus. Plus minus. So what do we have? X minus 3 equals positive and negative square root of negative 3. And adding 3, remember to squeeze it in right in front. X equals 3 plus and minus the square root of negative 3. Now there's that negative under my radical. I'm going to bring out an I, which means 3 plus and minus I square root of 3. So our two roots are 3 plus I radical 3 and 3 minus I radical 3. Notice they are not real. That means they will not cross the x-axis. We will not be able to point at them and say, there are the roots. What they are complex numbers. What we have are two unequal, complex, conjugate roots. They are conjugates of each other, which is kind of cool. Now I have a graph set up here just to connect the concept that the roots are imaginary with the idea that this graph should not cross the x-axis. So let's do the graph of y equals x squared minus 6x plus 12. Go ahead and put that into your graphing calculator. X squared minus 6x plus 12. I'm going to clear out all this from earlier in the unit. All right, I can put this anywhere. I'll put it here. X squared and I should have a pretty normal window. Let's try zoom standard. And there's our parabola. You can see doesn't cross the x-axis, which is a good indication that our roots are not real. Take a look at the table. I'm going to do a table set first. Negative 3 counting by ones. Let's change that to 0, counting by ones. And the table, so that you can sketch a little bit. 3, 3 is obviously the vertex. 2, 4, and 4, 4. So here, 1, 2, 3, 1, 2, 3, and 2, 4, and 4, 4, and and we had a sketch just like that. Let's label X and Y. Okay, very good. So again, our vertex, our turning point was at 3, 3. We can still use lots of things that we've already learned about parabolas. We could find the axis of symmetry, negative b over 2 times a, and there it is, it's 3. But we already knew that. So all those connections are still in play. We're just continuing with quadratics and parabolas. All right, try the next one. It says to solve using the quadratic formula. So let's remind ourselves what that is. There it is. For this quadratic, A is, B is -4, C is. Let's substitute that in. Don't forget this x equals negative of -4, -4 squared, positive 16, minus 4 times 1 times 13, all over 2 times a. So we're going to have 16 minus 52 . 16 minus 52 is negative 36. So we have 4 plus and minus square root of negative 36. We'd bring an I out, and the square root of 36. Nice, nice. So in this problem, we can simplify because 2 goes into 4 and into 6. 2 plus and minus 3i. So our roots split up are 2 plus 3i and 2 minus 3i. They are imaginary. 2 unequal complex conjugate roots. If you'd like, sketch a graph and you will see they are not going to intersect on the x-axis. The x-axis, we look for real roots to cross the x-axis, and our real roots will not. So putting in x squared minus 4x plus 13. Let's go ahead to the calculator. And don't know why I'm working down here, but it doesn't matter. And there we go, it's way up there. Matter of fact, if I wanted to see more of it, I would increase my y max. I'm going to take a look at the table. Let's see. I can tell that the turning point looks like it's at 2, 9. 2, 9. Axis of symmetry would be negative b over 2a. So definitely at 2. If we subbed that in, we would get 9. And we saw the 10, those 10 points on either side of it. So our parabola is way up there. Now let me connect this with another thing that we learned in this unit, and that was the discriminant, b squared minus 4ac. So I know, since I've already solved for the roots, that my roots are complex conjugates. They're not real. So I should find what when I determine the discriminant? I should find that my discriminant is negative, less than 0. So let's give that a shot. B squared minus 4 times A times C. This should look very familiar to you because we've already done the work. And there it is. Our discriminant is negative, which tells us our roots are complex conjugates or imaginary, which tells us that the graph does not cross the x-axis. All right. It says use completing the square. I would pause right now and try this one myself. And let's see what we get. Pause the video. Okay, if you rejoined me, we've got two roots. X equals -5 plus 2i, and x equals -5 minus 2i. So what's our parabola going to look like? You should be able to tell me all sorts of things about it. I can figure out the axis of symmetry. I could figure out the vertex. Let's go ahead and look. Awesome. There it is. My axis of symmetry, negative b over 2a, would be at -5. And you can see that there in the picture. All right, our last three questions. For what values of c, which is here, missing, does the equation 2x squared plus 5x plus c have imaginary roots? So this is information about the discriminant. And we know if the roots are imaginary, that our discriminant is less than 0. A is 2, B is 5, and C is C. So if I want to pick the next integer that's greater than 3 1/8, I would pick 4, 5, 6, etc. So we can take this equation now, we can check that. Let's try putting in a 4. Let's graph this on your graphing calculator and see what you got. bit longer to do that. 2x squared plus 5x plus 4. It's not going to let me leave that there. There we go. And there's our parabola. Now looking at it, you might want to zoom in to tell that it is not hitting the x-axis. You do zoom to enter, and there's a better look at it. So yep, we picked a good number for C so that our roots are imaginary. All right, next question. For what integral, that's how they're usually written, values of k, does this equation, there's k, have equal roots? What do equal roots tell you about the discriminant? Well, if the roots are equal, the discriminant equals 0. That's something you should remember. So let's substitute in. A is 2, B is -8, and our C value is actually k. So -8 squared, positive 64. So we've got 64 minus 8k equals 0. 64 equals 8k, and k is 8. Well, that means that this parabola, substituting in 8, should do what? What should this picture look like? Should hit just once. So let's go ahead and put that in. Almost done. That was a little easier to change. 2x squared minus 8x plus 8 . All right. 2x squared minus 8x plus 8. There it is. My picture was not right. Might want to zoom out, zoom back out, zoom 6. It's going to come down and just hit once, just at that one point on the axis of symmetry at the vertex. All right, last one, working with the discriminant again. When are the roots of a quadratic real? They're real when the discriminant, b squared minus 4ac, actually greater than or equal to 0, because these are real. But the greater than part is the part we're really focusing on. So we're looking at k. This time a is k, b is 6, c is 3. Let's substitute in. B squared minus 4 times k times 3. That's 36 minus 12k. I'm going to add the 12k over. And I have k. And I have a 3. If you want to switch that around, k less than or equal to 3. So let's pick a number less than 3. I could use 2, I could use 1, I could use 0, -1, lots of choices here. So in my, oh, I can't use 0. I lied, because that's the coefficient of the x squared. Let's use 1. So that would be 1x squared plus 6x plus 3. And I should see 2 real roots. And they would be unequal. So last one to go and put into our calculators. This has just been a little review of what discriminant does and how we can predict what the graph will look like. I'm going to clear this. And there it is. The parabola is crossing the axis in two places. That means two real roots. Okay, write down any questions that you have. The main goal of this section was finding complex roots for a quadratic, and then also connecting the idea of the picture with the roots that you get. Have a great day.